And the last is factorial. And then you mentioned something about infix, prefix, and
Okay.
suffix.
Okay, so we haven't talked about Fibonacci numbers. Okay, well.
Oh, you brought it up.
Okay. Okay, excellent. So that's what we're going to do today. First thing first, we have to define the subroutine, or better yet, let's go to Wikipedia and just take a look at the definition of Fibonacci numbers. So all you have to do is to look up.
Already up there.
Hmm?
Your third tab.
Oh, thanks. Okay, very good. This is the definition of Fibonacci numbers. It's basically a series of numbers. If you look at the definition, it is basically saying if f0 by definition is 0, f1 by definition is f1. But for everything else, you use this definition. This means that if n equals to 2, then f2 equals f1 plus f0. If you're dealing with f3, f3 becomes f1, f2 plus f1, and so on and so forth. Okay, let's just work out one case by hand first, and then we'll write the algorithm and then trace it. Let's just say that I want to figure out what is f of 3. Okay, basically the fourth item in the series. By definition here, 3 is not 1, 3 is not 0. I cannot use f0 or f1 in this case. I have to use fn equals fn minus 1 plus fn minus 2. But since n equals to 3, I can now spell this out as f3 equals f2 plus f1. Is that okay? Okay, well, that's kind of helpful, but it doesn't solve the whole problem, because now we have to figure out what is f2. f2, 2 is not 1, 2 is not 0, which means I have to use this definition again, except this time n equals to 2. When n equals to 2, f2 equals to f1 plus f0. Okay? f1, by definition, is 1. f0, by definition, is 0. So that means I can resolve what is f of 2 first. F of 2 just becomes 1, because it is 1 plus 0. Now that we have to figure out what is f of 2, which is 1, we have to figure out what is f1. f1 by definition is 1, so this one is equals to 1, 2, which means f of 3 equals to 2. Are we doing okay so far? We're just kind of following the definition of Fibonacci. And if you look up the series, it is correct, because f of 0 is 0, f of 1 is 1, f of 2 is 1, f of 3 is 2, f of 4 is 3, and so on. Okay? So basically, if you look at this list here, it spells out the first 12 or so numbers in the Fibonacci series, or sequence in this case.
So
Are we?
always starts with f0 equals 0 and f1 equals
Yeah.
1. That's always.
Yep, that's how you end the recursion, basically. Is that okay so far? So now we want to write a subroutine to compute Fibonacci numbers. And the way to do that is to define the subroutine called f, and I want to show both of them at the same time. How many parameters do I need? Okay, just take a look at the general form of f of n. I just need one parameter, which is n itself. And I can do it by value because I'm not changing it. Okay. Now, when I am inside the subroutine f, I have to handle the quote-unquote special cases first. In other words, if n equals to 0, I know the result right away. If n equals to 1, I also know the results right away. So I want to handle all the easy cases first, which means I have to check to see whether n equals to 1, because if that is the case, I just return 1. I can also check else if n equals to 0, then return 0, because that's also an easy case. Now, if it does not equal to 1 and it does not equal to 0, then I have to go through the trouble of invoking Fibonacci again. So in that case, it will return the result of invoke f, but this time we use n minus 1 to specify n, plus invoke again f, but this time we use n minus 2 to specify n. And if, and define sub. Let me do the indentation, and then we'll look at this code and see whether it actually does everything that the definition of Fibonacci is doing. There we go. So now we are comparing the definition in terms of mathematics on one side to the actual pseudocode on the other side. Do you think they are matching? Okay. So I think they're matching. It's just that, in the case of the mathematical definition, they don't use if then else to specify. If, n equals to 0, the result is 0. When n is 1, the result is 1. It's just that we are now formally coding this logic into pseudocode. If you try to write this program in any actual programming language, it'll be about the same as what we have in pseudocode. Any questions at this point? No questions? And the main program, let's just say that we want to print the result right away, so I'm not even going to bother with the main subroutine. I just want to find out what is the Fibonacci number when n equals to 3. So we specify 3 here as parameter n. That's all we're going to do. Go. And make sure we save the program first. Fibonacci. Okay. We do need one column for comments, not only because we have a print statement, but also we have a conditional statement. We need one column for line number, and that's all the columns that I need initially. The precondition, there's nothing to say because we don't have any global variables whatsoever. And we start execution on line 11. Line 11 invokes f. Oh, wait. Do we want to invoke f? Can we print something right away on line 11? We don't know what to print until the invocation of f is done. Okay, so that means, do we use a return line number or do we use return info? Return info, because it gives us more information about what to do when the subroutine is done. Okay, and if you remember from last time, when we specify return info, we don't specify just a line number anymore, because if I just want to specify a line number, it's just going to be line 11. I have no idea what on line 11 I'm supposed to do next. So in other words, in this case, we have to spell out line 11, and we have to spell out the operation that will not have been done by the time we get back to line 11. And in this case, the print portion would not have been done yet, because that cannot be done unless we know what value we're supposed to print. The invocation that we are dealing with, which is invoking f, is replaced by a single question mark because it is a placeholder for us to specify the return value of the subroutine. It also has a parameter n. In this case, it is passed by value, and it is just a constant, which is 3. So column D is fairly easy to specify. It just has a value of 3. Do we have any questions at this point? Yep.
Would you docketing points if we did unknown and then we entered 3? Right?
The answer is yes, because a parameter, a pass by value parameter, is different from a local variable because it has a known initial value. Not a whole lot, okay? As long as I can see that the value is there before you get into the subroutine, there won't be a whole lot of deduction. But technically speaking, it should start with a value and not the question mark. Okay. Any questions about column C and column D, how they are set up? No questions? Okay. Well, that kind of ends the easy part of this algorithm. Because everything else is going to be a little bit confusing. Not hard, okay? There's not a lot of busy work in this case. It's just, confusing, okay, which subroutine are we invoking at this point? Which invocation are we dealing with? So you have to kind of follow that logic closely as we work out the trace here. After line 11, we go into the subroutine. We go to line 3. Line 3 is the first action line of inside the subroutine, so we start with the execution of that line. Easy enough. We're just comparing n to 1, and the answer is false. N is 3 at this point. 3 does not equal to 1. Then we go to line 5. We check out the other condition. N equals to 0 is also false. So now we have to go all the way to the else portion, which is on line 8. Line 8 is going to return the result of 2 invocations of invoking f. Okay? So that seems kind of confusing, but we have done it before. We have done something like this before, just not in the context of a return statement. If you look at line 8 here, can I return right now? Do I know what value I'm supposed to return? No. Now how would I find out what value I'm supposed to return? I have to invoke f twice, right? I have to invoke it once with the parameter n minus 1. I have to invoke it again with n minus 2 as my parameter. You can actually technically pick which one you want to go first. Okay, right-hand side first or left-hand side first really does not make any difference in this case. But because most people read from left to right, we'll just follow that convention in this class. Which means on line 8, we will take care of this invocation first. And every time you invoke f, you have to do the same thing. You have to specify return info. And we have to spell out the entire line except for the invocation that we are dealing with. So we have to spell out the return. This is the part that we cannot do yet. The invocation, the first invocation of f is the one that we are dealing with right now, and that's why it is a single question mark. But the second one is not done yet. So that's why we have to spell that one out exactly the same way as it is written in the pseudocode itself. And I know I just have to rearrange the windows a little bit so we can see both the source code and also the trace at the same time. So we'll use about the same trick as last time, except this time it does not leave me as much space over here. I can do something like this. I can turn off my toolbars. That gives me like 2 additional lines. We have to use column F to specify my parameter n. Oops. Put it here. The question is, what am I going to put over here? Every time I invoke subroutine F, it expects a parameter n that is passed by value. So in this case, what am I going to do, or what value am I going to pass to parameter n? According to the code here, I'm supposed to use n minus 1 to specify the new parameter n. Which n am I talking about when I say n minus 1? Column D, and column D has a value of 3 at this point. In other words, this new n or column F will have a value of 2. 3 minus 1 is 2. And once I have set up all the columns, we can continue execution in the subroutine starting on line 3. Line 3, now this is going to get really boring, after a while because it's all the same. N equals to 1 is false. N equals to 0 is false. We end up on line 8. And what does line 8 do? About the same thing. Okay, line 8 is going to do about the same thing.